And welcome to the Daily Space Weather Show. We've got one new sunspot here and a general decline in solar activity. If you're frightened that the sun is shutting down, we'll tell you why it isn't. There is a higher likelihood of large solar flares. We had a nearly M-class flare just earlier this morning. We'll talk all about it and lots more today at the Smash News Network, least busted name in news. This is a 24-hour video from SDO. That's ionized helium and iron, 304 and 131 angstroms respectively. Let's take a little closer look here. A new sunspot did form up there in the northeastern limb. It is very small, and so far it only looks like it's alpha class. That means its likelihood of producing a large solar flare is not there. There are a number of large plasma filaments on the solar disk, so you can expect coronal mass ejections to continue. One of them is visible toward the right of the screen there. That dark absorption feature, that's been named as the Mike Smith solar filament. The most likely place to see large flares is now in the western limb. So both that northern and southern sunspot group have the sort of magnetic field complexity we would need to see a large solar flare. So don't be surprised to see that occurring. Actually, there has been some recent activity in that sunspot group there in the northwest. Moving to the southern hemisphere, there's the full view. Let's get a little bit closer to that group in the southwestern limb. Here's a fantastic view of that. That group also harboring complex magnetic fields. And as it gets closer and closer to the limb, it is more likely to produce a large solar flare. Next, let's take a look at sunspots briefly here using there is the SDO continuum. And a little bit of evolution of this group here, a little bit of evolution of this group here. But besides that, not a lot going on. Again, a sunspot did form up here. It's a very small little pore that opened up. It'll be more evident here on the colorized magnetogram. By the way, these two SDO browse data features are showing yesterday, August 11th, plus today, August 12th, to date. By the way, if you enjoy the content, please support the channel. One of the ways you can do that is by picking up merch. So this one was a viewer-submitted request. Somebody wanted some Smash News Network least busted name and news products, so we accommodated them. If you'd like to help get the word out there about the world's most comprehensive daily space weather and the most detailed solar imagery you'll find in the known universe, perhaps pick up some Smash News Network logo products. It does feature the YouTube URL and, of course, the Smash News Network logo that you're so used to seeing. That one right there. By the way, thanks to everybody who has picked up merch over the years. You can find a link below this video in the description, as well as on our homepage, smashomash.com. And welcome to the Neo Renaissance. Congratulations on realizing that the channel exists. Let's take a look at what's going on planet Earth, or as you may know it to be, Croissant Earth. Yes, Croissant Earth. Stop believing NASA's lies, folks. Earth is not shaped like an oblate spheroid. Everybody knows it's shaped like a croissant. At least everybody that views our channel realizes that it's shaped like the French breakfast pastry. Not an oblate spheroid? What are you talking about? NASA's totally incentivized to convince you Earth is shaped otherwise than as an oblate spheroid. Pardon the sarcasm. Here's the volcano list. Subanosejima is erupting, producing a 6,000-foot ash plume. Mayan producing a 9,000-foot ash plume. Bagana, 7,000-foot ash plume there as it explodes. Quite a few volcanoes here currently erupting. Ibu exploding, flight level 070. That's a 7,000-foot ash plume. Luatolo, 8,000 foot ash plume there. Semeru in East Java, Indonesia, exploding, flight level 140. And they're getting larger and larger as we move farther south. Guatemala, not sure if Sancha Guido is erupting. However, Fuego certainly is, producing a 16,000 foot ash plume as it explodes. It's a flight level 160 and a flight level 200 over the Ecuadorian Sangay volcano. Sabancaya producing continuous emissions. No idea about the ash plume altitude there. Ubinas, not sure if that is erupting in Peru. Please do not pole vault the caldera. Next seismic activity, and it's been quite low here over the past 24 hours. I'm not even sure if there were any quakes of a 5 magnitude or higher, but we'll go over it. So, wow, a very, very low number of earthquakes here. And I don't think there are any 5 magnitude earthquakes over the past 24 hours. So I'm just going to let the list scroll here. Let us know in the comments if we missed anything. Let us know in the comments whatever you'd like to let us know. And it's time to return to space. Yes, space, you're from there. There's the past 24 hours in SDO 171 angstroms, the house favorite wavelength. So that awesome looking active region up there in the northeast, that would be up here. Not a lot going on there. We thought there'd be a sunspot rising there, but indeed not. There is a lot of plasma suspended out there and all over the Earth-facing portion of the solar disk. So again, don't be surprised to see coronal mass ejections continue. In fact, that's a forecast. Coronal mass ejections will continue. There is a 99.9% chance of coronal mass ejections continuing in the next 24 hours. The 10.7 centimeter radio flux here, a little bit stalled at 153 solar flux units. And there is the 1 year chart. The sunspot number is depicted by the red line. The black line depicts the radio flux. The pink line is the 30-day Wolf number. That's the sunspot number average for the 30 days. And let's talk about why we are not seeing a grand solar minimum. So, first of all, if you are relying on Zarkova's forecast for solar cycle activity, she forecasted a lower solar cycle than solar cycle 24. It is all based on an analysis of the magnetic dynamo. All right. Now, it's not like she did bad math, because the magnetic dynamo is the magnetic dynamo. And, extrapolating a pattern there from the magnetic dynamo is a thing. However, if you don't have the inputs on how the magnetic dynamo is created in the first place, you're not going to get, it's a garbage in, garbage out sort of a thing. And anyway, Zarkova forecasted a weaker solar cycle for solar cycle 25, and we're seeing a stronger solar cycle. So she couldn't be more incorrect, because if you expect a trend to go down, but the trend goes up instead, based on statistical analysis of the magnetic fields, then you've made a forecast that is opposite of reality. So here's the radio flux. So here's solar cycle 24. The peak was 122. Here's solar cycle 25. Still not at the peak. Monthly value 122. Monthly value 184. 182.47. See what I'm saying? It's clearly a much stronger cycle. In fact, my forecast is that solar cycle 25 will be a stronger cycle than solar cycle 23. By the way, we are seeing cosmic ray flux levels at levels not seen since 2006. So here, looking at the sunspot number also, showing a similar trend. Solar cycle 25 has already exceeded solar cycle 24. The peak of solar cycle 24 sunspots was about 112. And we've seen them as high as 143. There you go. There's a monthly value of 143. So it's not even close. This Zarkova forecast is not representative of reality. Again, she didn't screw up on the math. Her inputs were just based on statistical analysis of the magnetic fields. But if you don't have the inputs for how the magnetic fields are generated, then you might be missing some variables in your analysis. Now, space is very empty in between the Earth and Sun right now, so there is really not a lot going on. Space is very, very much like a vacuum in between the Earth and Sun at the moment. There's not a lot of plasma out there, all right? So, and NOAA agrees there is no space weather on the forecast here. Only a tiny little uptick in the KP index on the NOAA forecast there, coming on Monday, August 14th. So, very low levels of solar activity here. However, coronal mass ejections will continue. And fingers crossed that some of those will be directed toward Earth. So, here are the past 4 hours of Earth's magnetic moment from space. We show it daily on the channel. Partially to allay people's fears that the poles are going to flip, as these have been steady for years and years. We've been doing these daily space weather videos for like 6 years now, over 6 years. So there are the past 4 hours of Earth's magnetic moment from space, and it looks just fine, just like Earth's magnetic moment from the ground. If Earth's magnetic excursion was an extreme magnetic excursion, we'd see quadrupoles. We'd see weird areas of high magnetic flux density all over the planet, but we don't. That's the last 4 hours of Earth's magnetic moment from the ground, and things look just fine. Your finest days lie ahead, and while things can certainly get worse, much, much worse, they'll get better. Planetary K-index currently at 2.33. That's 2.3, by the way. It is a geomagnetically calm situation. Now, we are seeing some variations in the solar wind here. That is the active spacecraft there is the ACE. We're seeing variations here between 3 and between less than 1 proton per cubic centimeter. So a very diffuse solar wind out there. And that's likely magnetic, what we call, you could call it magnetic flip-flopping, because keep in mind the solar wind is constantly subject to magnetic fields, and of course the more diffuse the solar wind gets, the more of an effect those weak fields have on the solar plasma. Keep in mind that is measured at Lagrangian point 1, about 1 million miles away from Earth outside the magnetosphere. The current conditions are showing up here just under 2 protons per cubic centimeter, pretty unremarkable, and actually very diffuse. And solar wind speed here just over 400 kilometers per second at 430. Here are the GOES magnetometers, pretty smooth here over the past 3 days. No surprises there. Again, there's been a very low amount of space weather activity. Those ArcJet moments there, those are not NASA hiding data. Those are NASA showing you that, actually it's NOAA showing you that the spacecraft had to turn on their thrusters and maneuver, which can create anomalies in the in the magnetometer data. All right, so next, our top view ecliptic plane field plot. Earth is just in a south pole current sheet. Nothing to write home about there. It is steady as she goes as far as the heliospheric current sheet. You bring up the latest image, you see Earth is right kind of in the middle of that red area there. That is the south pole oriented current sheet. North pole current sheet shown in green. Here's our line of sight field plot. Solar B field in blue. North solar polar field in green, south solar polar field in red. And the grayscale is the gong magnetogram. And next, coronal holes. Now, some of us believe that coronal holes are actually more important to the analysis of a sunspot cycle than sunspots. I know it sounds like blasphemy, right? But counting sunspots is, it might be, well, it's important. However, I just don't think it's as important as coronal holes. And our Gold Smash team members probably know why. It's because I've come up with a theory that is a bunch of crap. I've come up with a crap theory, CRAPF. And no, I can't tell you what the acronym stands for. That costs you $9.99 a month to get that information. And let's look at coronal holes here via the SDO. All right, so there's a great 24-hour video. That north hemisphere coronal hole there, that is of south pole orientation, I think. Yes. So as the solar polar field reversal process goes on, the north solar polar field migrates to the south and vice versa. If you bring up the latest image here, there you go. Actually, that is a north pole coronal hole. All right. So there's a view of that once again. Keep in mind, at solar minimum, those coronal holes are constrained around the polar regions. So there's a long way to go for the north polar fields to make it all the way to the south polar region. And we'll keep monitoring it and showing you updates on the daily on the channel. Next, we'll move to sunspots. So first, we're going to show the SDO continuum here. And there is yesterday plus today. That's August 11th plus August 12th to date. So again, there is one new sunspot that'll likely get a name today. It's up here in this active region. You can barely even see it, if at all, on that imagery. We'll show you high-res images of it later. So far, it's only an alpha-class sunspot, meaning it only has a North Pole umbra. No South Pole umbra yet, at least when I did show prep. And let's take a look at the Integrated Space Weather Analysis Center's flare probability monitor and magnetogram. So it'll be sunspot 3401. Should be the name of this group up here. 3401 should be that new sunspot. And again, the likelihood of large flares rising as these two groups approach the western limb. Next, we'll look at energetic particles, like solar energetic particle events. There is the GOES proton flux for the past 3 days, subsiding back down to its baseline levels. And those polar radial blackouts have subsided about 2 days ago. Those polar radial blackouts occur right around that 10 mega electron volt warning level, that red dotted line that you see there. And we have a second solar flare today. So this C9 flare was happening just about as I was jumping out of bed. C8.86, it looks like, was the peak flux of that, around 9:15 Universal Time this morning. And then another double peak, longer duration, high-level C-class flare, a C6.62 happened this morning. Those are the two most significant intensifications. X-ray flux here now dipping back down again. So again, solar activity has been dropping. And if you're worried about the sun shutting down, that is just not a thing. It's just, I don't know what to tell you. If you're in the grand solar minimum cult, please exit cult stage immediately. Let's talk about Perseids as we look at what's overhead over Lehigh Valley, Pennsylvania. We've got a lovely crescent moon there. And so that's one of the ways you can figure out where Perseus is located. It is just to the northwest. So there's the moon. Perseus is to its northwest, right about at our zenith right now. So maybe bring a lounge chair if you're viewing the early morning sky to view the Perseids from the northern hemisphere. And let's just advance this to show you what it's like at the dusk sky. So when the sun first sets, let's go back 1 hour here. So as the sun sets, you've got Venus here showing up at the wrong place now. So Venus is now becoming a morning star once again. However, you do have Mars and Mercury there trailing the sun. So there's the dusk sky. Let's go back another couple hours here. So there you've got Perseus way up in the northwest. And that's actually going to set before the sun. But then it's going to come around. So it'll rise in the northeast there. So again, Perseus right there. And the area that you can expect the Perseids to come from is the area sort of at the border between Perseus and Cassiopeia. So that's sort of where you can expect to see those. We use skyandtelescope.org's great star chart. So the northeastern sky is where you'll see the Perseids, perhaps. And then it will rise higher and higher in the sky, approaching your zenith just before sunrise. So that's where you can expect that. Next, your solar system forecast. And let's pause for station identification. Thanks for tuning into the Smash News Network. Least busted name in news. Here's your solar system forecast. This is where things are today. We've got this crescent moon as we approach the August new moon, which is on the 16th or 17th. I don't know exactly when it's completely new. I'm not that concerned about it. We'll advance this solar system model 1 week. This is, by the way, theplanetstoday.com. And keep in mind, it is not to scale. Planets are really far apart. They're not to scale because we need to fit them on the screen. Here's your 1 week solar system forecast. Here's where things will be on the 19th. And let's move to coronal mass ejections. Yes, coronal mass ejections. We've got some interesting imagery for you today. Actually, we've got 2 more stories for you here that I forgot to cover. The astronomy picture of the day, which is a guy tapping on his telescope to create these little streaky images here. That would be I'm not sure who's doing that. Paulo Palma, credited with those images. apod.nasa.gov if you want to look at those yourself. And you can see some binaries like Arturo and 26 Ophiuchi. And let's talk Parker Solar Probe. So the Parker Solar Probe is the fastest object ever known to be built by mankind. Maybe some ancient culture built a faster craft than this Parker Solar Probe, but Parker Solar Probe, the fastest object ever built as far as we know. And not only that, it's the object getting the closest to the sun. So you may find a story on SciTech Daily about this. It had to make a little adjustment to its Venusian gravity assist. It'll be reaching a speed of 394,000 miles per hour, and it will come within 4.5 million miles of the sun on September 27th. By the way, you can find out more about the Parker Solar Probe if you like. There is a whole series of information about it on NASA's web ring. So check that out if you like. And let's move to coronal mass ejections. So some CMEs happening here, coronal mass ejections. I don't anticipate those to be earthly directed CMEs. So that is yesterday's imagery from George Mason University. That's 89 frames at 12 frames per second. And here are today's images, an additional 34 frames at the same frame rate. Those are not earthly directed either, just minor outflows happening so far today. So here's Soho Lasco C2 and C3, and we're going to zoom in a little bit closer on those. And by the way, we've dropped stereo A from the coverage for the moment because it's showing some erroneous looking data. If you've got ideas as to what's causing stereo A to look so weird, its coronagraph is not looking like it's legit. So we're instead just showing Soho Lasco C2 and C3. And I just want to talk for a brief moment about the way coronal mass ejections evolve as they move through the solar system. So they're all different types. Some are very dense, some are very diffuse. This one here is interesting because it's got different features at its core. This area right in here, it's got different core features than it does these outer features. And we're going to show that here because these things do evolve as they eject. So it is actually two separate events going on there also. So there's like sort of one behind that CME. But you'll notice that as this comes out, the outer region diffuses more quickly than that inner core. The inner core even looks like it ejects sort of separately there. So that's a great example of, if that would strike Earth, you would see a density increase, and then a lull in the density, and then a gradual, really high density increase, and then another lull in the density. So again, CMEs looking very differently from each other. We'll let those play through on the Lasco C2 and C3. Again, those are not earthly directed. Just a bit of a solar plasma light show going on there. Again, you can expect coronal mass ejections to continue for the next 24 hours. Tomorrow, on our daily space weather video show, we do indeed expect to show you more coronal mass ejections. And let's take a look at our custom images here. But before we do that, let's go back to solar flares. I forgot to show the solar flare images. So here's 94 angstroms. That's a 24-hour video from the SDO, Solar Dynamics Observatory. Yeah, the most active region has been this group in the west. And we'll also show 131 angstroms. And here come some coronagraphs. So some extremely weird anomalies happening there on the Soho Lasco C2. Not sure what that's all about. But if you've got theories, leave them in the comments. We didn't see that on the other Lasco imagery that we showed, so that looks dubious. I suspect there's something going on with the contrast or something like that with the instrument. So let's look at filaments here. First, we'll show the ground-based hydrogen alpha imagery from El Teide, Spain. And check it out, there's some plasma reorientation happening just south of the Donna Marie filament. We've got several of these filaments named, folks. This is the Donna Marie, this is the Kate Bush, and this is the Mike Smith. And we'll talk about naming filaments here in a moment. There's the latest image. Again, lots of large filaments on the Earth-facing portion of the solar disk. We also like to show the gray imagery here because it shows prominences. So it's still hydrogen alpha, but it's going to show the edge of the solar disk. And prominences are Well, there are a bunch of prominences pointed toward Earth right now. All of these dark absorption features, those are plasma filaments that are kind of suspended by magnetic fields up in the solar corona. They're pointing sort of at you at the moment, especially this one. So fingers crossed that that one ejects. And let's talk about naming filaments. If you'd like to name filaments after living people, we've been doing it. The largest solar storm of solar cycle 25 was actually named after Tamitha Skov. Dr. Tamitha Skov, I'd say the sort of the leader in space weather period. We just happened to name the filament. It came from the southwestern limb after Dr. Skov. Again, if you want to name filaments after living people, just join us over on Twitter. Follow the hashtag #NameThatFilament. Plasma filaments are lively, just like living humans, so that's how we name them over on X, the platform formerly known as Twitter. And let's take a look at filaments here from our SDO custom videos, because they are totally sweet. Hang on a minute. All right, there we go. That's another 24-hour video from SDO featuring 193 and 304 angstroms, ionized iron and helium. So here are some more eye candy views for you. And these wavelengths do give great contrast and depth to the solar corona, the sun's atmosphere. And we'll zoom back out and show the full disk once again. And then we'll switch to the current imagery. Those were 24-hour videos. This is about a 2.5-hour video. It's the GOES 16 SUVI, 304 angstroms ionized helium. And of course you can see some plasma splashing around up here. Also some activity down here and some limb darkening. So this could be a CME happening right now, this area right here. I expect that is a CME, and that could be an earthly directed coronal mass ejection. So without further analysis, it's going to take a few hours for that data to come out, probably, folks. Fingers crossed for an Earth-directed CME, especially with the space in between Earth and Sun so clear like it is now. It would be a great time to see a CME, as it would have a good impact and possibly produce aurora at mid-latitudes. Next, our bonus features segment, starting out with satellite charging hazards. We do have some surface charging hazards there over the eastern Pacific. They are minor, as electrons build up on the outside of spacecraft. GOES electron flux here, just in a sort of a normal operating range, a little bit on the high side. That's the past 3 days, as measured using radiography from the geosynchronous orbits of GOES 16 and GOES 18. There's the one-year graph to put that in context. Moderate to high levels of electron flux at the moment. There's the NOAA forecast, expecting fairly flat levels here for the coming days. No argument from me there. And next we'll look at the ionosphere, which is the layer where that is measured. The F layer is what we'll be looking at next. It is located at an altitude of about 300 kilometers. Here is the vibrational frequency, courtesy of Australian Government Bureau of Meteorology. And I don't anticipate any major anomalies happening in there. If you are seeing anomalies, they'll most likely be centered around the South Atlantic anomaly, which is located right about here, sort of in the middle of the South American continent there. It is the weakest spot in Earth's magnetosphere, and the area where you'll see the most variation in the ionosphere. It's like a huge divot in Earth's magnetosphere. Here's the anomalygram depicting anomaly in megahertz from the 30-day median. and the ionosphere looking normal and healthy as you may expect, with no major variations happening in there, as it is, again, geomagnetically calm conditions as the Earth system strives to reach static equilibrium, like everything in nature. Anyway, here's the latest image. That's 11:15 universal time on the ionogram and 11:15 universal time on the anomalygram. We also show total electron content. This will show you the most likely places to see GPS errors on the Earth. If you are expecting GPS errors and there are Wi-Fi hotspots around where you're navigating, try turning on Wi-Fi location accuracy, which uses known physical IP address locations and your Wi-Fi signal to help determine your location and help you navigate. And things are fairly organized there for the total electron content. The free electrons to about 12,500 miles of altitude. Now, unfortunately, the North American total electron contents here are jacked. They looked weird yesterday, and oh, that one loads. All right, just the anomaly is not going to load. All right, how about the standard deviation? And it's looking like it is jacked. Let's just ignore that and move on. Close out the space weather section of this video with the latest solar intensity gram seen here, and the latest colorized magnetogram. So let's take a look at first this new group. Again, it is fairly unimpressive. In fact, it's barely even a sunspot. It is an alpha class sunspot, as it only has one polarity umbra, which is North Pole, by the way. Next, let's look at these more complex groups, starting with this one down here. That is barely a beta class sunspot. It does have some trailing umbrae there. It is beta gamma class, making it more likely to produce a solar flare than a simple alpha class sunspot. And last but not least, let's check out these groups here. I think I can fit all three of those. It looks like we can. Yes. So there are three more sunspot groups. This one is alpha class. This one is beta gamma delta class. So it has been the most active sunspot here in the past few hours. You can expect that to continue or even increase here as it gets closer and closer to the limb. This group over here is also beta gamma delta class, but barely. And the deltas are in this trailing umbra back here. So they are minor though. That's barely, well, there's a minor delta up here also. So two beta gamma delta class sunspot groups. This one right here is the most likely to produce a large flare. That one right there. Let's move to meteorology. It is one of our value-added services, which we used to separate from our daily space weather videos, and that caused less views to show up. So that makes a lot of algorithmic sense, right? We're looking at Saharan dust here. So the likelihood of hurricanes, especially in here, is about 0%. That is very, very dusty. And the Saharan dust is fantastic because it actually fertilizes the Caribbean. It's part of the reason why the Caribbean is so lush. And again, it tamps down systems, so it helps to prevent convection in the Atlantic, reducing the likelihood of hurricanes. So sorry if you are like one of these disaster enthusiasts. That's going to make disasters in the eastern U.S. significantly less likely. Let's move on to our surface winds and jet streams. There are the surface winds of the east. There is a typhoon here, southeast of Japan. Here are the jets of the east. Here are the jets of the central world. the 250 hectopascal winds. Here are the surface winds. And the surface winds of the west. Powerful low here, south of the Alaskan Peninsula. That is a large and in-charge low. Here is the jet stream scenario for this side of the planet. Fairly coherent jet stream over the U.S. and a bit of a convergence happening over the central part of the country. Let's take a look at our windy.com satellite map. As the sun rises over the Mississippi Valley. That is the visible satellite animation. Windy.com, they've got a great mobile app. Check it out. If you're watching the video, windy.com, reach out. We need affiliates and sponsors. I think they sponsor Reed Timmer. Did you know that? Let's take a look at clouds and fog. This is the shortwave radiation map from the NASA GOES Interactive Weather Satellite Suite for the Americas. Great equatorial cloud bands there. And here's your weather.gov map. It looks like some extreme heat advisories in the Pacific Northwest. Excessive heat watches up there, I think. And some serious weather around Alaska as a result of that low that we showed you earlier. Next, some forecasts starting out with the jet stream, the 250 millibar. Winds are depicted here. That's the 72-hour GFS forecast. It's going to be pretty cool around the Great Lakes in the coming 3 days. Here is your temperature anomaly forecast in degrees Celsius, and check out the temperature anomalies up there in places like Washington and Oregon. Going to be seeing 16 degrees Celsius above normal for this time of year. That is exceedingly hot. Again, that is your 72-hour GFS temperature anomaly forecast in degrees Celsius. Here is your pressure and precipitation forecast on the same model, the 72-hour GFS. Some strong storms here are going to form over Iowa in the coming days. We talked about it yesterday, and this forecast is confirming it. Moving on to Lightning Mapper. There are the current lightning strikes. Missouri seeing quite a bit of lightning there. Quite a bit of lightning across the U.S., but no ultra extreme events. Let's check out a real-time lightning map to see if there are any current strikes. Is there thunder rolling in anywhere? Next time you hear thunder, check out lightningmaps.org. You could use it to forecast thunder. It's just awesome. So there are some cells here south of St. Louis around the Mark Twain National Forest. By the way, folks, never blame a conspiracy for something that can be more readily attributed to basic ignorance and stupidity. Ignorance and stupidity, it's a thing that we're reducing by putting out these videos. So press like and subscribe if you're new to the channel. Do yourself a favor and have our videos on your subscription feed. Why? Because our thumbnails contain more valid, relevant information than entire channels' repertoire of content. It's just a fact. There's a lot of data on our thumbnails and a lot of nonsense on YouTube. We are a pseudoscience-free channel. Congratulations on realizing it exists. If you want to support the channel, visit our links. You can find them at smashomash.com, our homepage that we painstakingly built back in February of 2019 is when we launched smashomash.com. And the huge web ring that we've created, including a forum, our mission statement, links to our Hemp Lucid paid affiliate sponsor, our Spotify, which is Golden Cap Productions, our record label. Don't forget Amazon. There's a link to the Redbubble shop. Also to the Smash team. You can find us on Instagram, Facebook, and all over the internet. Again, welcome to the Neo Renaissance. And if you want to support the channel and get additional content, then become a member of the Smash Team at smashomash.com/Smash Team. There's a bronze level, which will cost you $0 per month. You'll still get additional content. There's a silver level, which is $2.99 a month, which you'll get even more additional content. And then there is a gold level, which will get you even more additional content and things like a custom email address, perhaps most first names still available. If you'd like Steve or Pierre at smashomash.com, become a gold member, a gold Smash Team member. There's also an annual paid-up subscription, which is the best value, as it's almost like getting 4 months for free. It includes complimentary merch. And let's close this thing out. We'll show you Doppler radar, clouds and fog, and the water vapor map. So here is the U.S. Doppler radar showing the full 50-state view. We're going to focus on the lower 48 view. Louisville, Kentucky is going to get some rain here. Those systems are moving to the southeast. A normal way for storm systems to move. Here is clouds and fog. That's the shortwave radiation map. And there is the water vapor map. Once again, there's a constrainment and a compression happening here. There's an impulse from this dry mass of air, part of the jet stream complex. And then there's a collision happening right here as this relative low strikes this wall of dry mass of air to its southeast. So that creates huge pressure gradients. Huge pressure gradients create things like lightning and precipitation. And here's your recap. U.S. Doppler radar. Clouds and fog. And there's the water vapor map. Turn to the water vapor map if your Doppler is unclear. Hopefully we've made things clear from what's going on from the sun all the way down to here. Anyway, thanks again for tuning into the Smash News Network, least busted name in news. We'll see you soon, maybe even producing more video today. Who knows? It's possible. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. It's bunker time. Whoa!